Hello, welcome to Adding and Subtracting Polynomials. I know you're extremely happy to be here learning math, as I am happy to be here teaching it. This is pretty much the foundation of our Chapter 7, and it's going to be the things we do today is the foundation of everything we're going to do in Chapter 7. So a good understanding of this is necessary to do the rest of the things we need to do with polynomials in this chapter. So we're going to get started with some vocabulary words. The first one, monomial, okay? And I've got something real formal here. It's a real number, a variable, or a product of real number and a real number and one or more variables with whole number exponents. So what we're talking about is this. So it's a number or a variable or a product of both. So something like that would be a monomial. Okay, something like this would be a monomial. Something like this by itself would be a monomial. But if I do not have a whole number exponent, let's say I have to the 1/3 power, that's a problem. I can't do that. Okay, I can't have a negative exponent or a fraction for an exponent. So I've got to have whole number exponents. That's 0 on up, positive whole numbers. And it's basically the monomial stops when you have a plus sign or minus sign. So it can be as long as we want it to be, but as soon as we stop multiplying and we put a plus sign, that monomial stops and the next one starts. Okay, so that is monomial. Monomial one term. Okay, just one term. Okay, binomial is basically the sum of two monomials. So if I write a monomial here and a monomial here, and I add those together, that is a binomial. Binomial. Okay, both of these are monomials because I have a whole number exponent, and I can't combine those and make one, so that is a binomial. Okay, a trinomial, as you would think, is just three of those, three monomials added together. So if I had something like this, like 3x minus 4, that is a trinomial. Trinomial, three terms. So binomial, two terms. Trinomial, three terms. Okay, a polynomial is a monomial or a sum of monomials. So if we have one or we have many added together, we call it a polynomial. Poly meaning many, I believe. Polynomial. Okay, and the last thing we're going to look at today is the degree of a term. It's the exponent or the sum of exponents in the term. So this is a term. A monomial is a term. And to look at the degree of a term, we look at the exponents, not the exponent on the number, the exponents here on the variables. Okay, we don't look at the coefficients, look at the variable part. And that gives us the degree of the term. So we would say this has a degree of 3 or this has a degree of 4. Okay, if we looked at this, we would sum the exponents. That would have a degree of 5. But as soon as the addition sign happens, we stop adding the exponents. Okay, so if we're looking at multiple terms and looking at degrees, we do not add across addition or subtraction signs. We just add within the term. And that is degree of a term. So that should get us started with this lesson. So we just talked about the degree of a term or the degree of polynomial. A polynomial. We'll expand this a little bit. I have some very basic problems here to work, but we'll expand it a little bit and look at it a little more in depth than what I have here. So if I look at the first one, the degree of the polynomial, we're looking at the variable part and we're looking at the exponent on it. Yeah, it has an exponent of 1, so we say that has a degree of 1. Has a degree of 1. Now all of these are monomials. They're still polynomials, but it's a monomial. More specific name for that. This one, I look at the variable part only and I want to add the exponents. That is 3 plus 2, which is 5. So we have a degree of 5 for this monomial. This monomial has a degree of 1 plus 1, which is 2. We have to remember those have exponents of 1. Okay, this one has a degree of 0. There's not a variable, so there are no exponents on the variable. That it simply has a degree of 0. Okay, not necessarily. It doesn't mean it's to the 0 power. We just had exponents a little bit ago. It just means it has a degree of 0. Okay, just think of it as having no exponents on the variable part or no variables. This one has a degree of 4 plus the 1 on the z, which is a degree of 5. And this one has a degree of 1 plus 2 plus 1, which is 4, a degree of 4. That is how you find degrees of monomials. Now let's look a little closer at polynomials. I'll put one example here. Let's say we have this and we have that. I'm just going to go with 3's all the way down to make it easy. Okay. Now, all of these have degrees. Each of these in this polynomial, there are 4 terms here, each of them have their own degree. This one has a degree of 3, this one has a degree of 2, this one has a degree of 1, and this one has a degree of 0. So we say the degree of the polynomial is the largest out of all of these. So we would say the degree of the polynomial is actually 3. So when you have more than one term you're looking at, you find the one that's the highest degree, and that's the degree of the polynomial. Okay, so if I had x2y4 plus x6 plus y7, this has a degree of 6, this has a degree of 6, and this has a degree of 7. So we would say this polynomial has a degree of 7. Again, we don't add across the addition signs. We take the largest of the 3 degrees, and the largest is 7. Okay, I think that adequately defines what degree is and covers basically what you're going to see in this lesson. In example 2, we're going to look at adding and subtracting monomials. Adding and subtracting monomials, and you would know it as adding like terms. Okay, so I just have basically 4 examples here because they're not really difficult to do. These 2 terms, we have to make sure the variable parts are the same. This has an x with an exponent of 1, this has an x with an exponent of 1, so they are like terms, and we can add the 2 monomials together and we get 8x. And that's it. Okay, we've done that before when we've solved equations and things like that. But this is just adding. All we were doing was adding monomials together. Okay, here we're going to add these monomials. Actually, you're subtracting. Okay, so it's 4y minus y. You have to think of that as a 1y. So 4y minus 1y is 3y. And remember, when you add or subtract, you do not change exponents. It's only when we multiply or raise to another power. Adding does not change the exponent. It stays the same. Exponents mean you're multiplying multiple times. We're not multiplying here, we're adding. Okay, I've got an x4 and an x4 here, so these are like terms. So 11 and negative 6 should give me 5x4. And that's it. Okay, here notice both of these have x1, y2, x1, y2. So 2 minus 7 gives me negative 5 x1, y2. And just a note about this before we move on to the next example. Let's say this was 2y2x. It shouldn't be, but let's say it was. These are both still the same terms. They have the same variable part. Just because it's out of order doesn't mean it changes anything. It should be in order, but just in case it's not, you have to look. It has an x1 and it has a y2, so they're like terms. And when I put them together, I still get the same answer. Okay, and that's example 2, adding like terms. Example 3, classifying polynomials. Okay, we're going to write a polynomial in something called standard form, and we're going to name it based on its degree and the number of terms it has. Okay, so standard form means putting it in the order of its degree from greatest to least. So if we look at this first one, this one has a degree of 2, this one has a degree of 1. To put it in standard form, I need to put this one first. Okay, so 4x squared goes first, 3x goes second. That is now in standard form. Okay, because the highest degree is first. Now we're going to name it based on its degree and the number of terms. Well, the highest degree is a 2, so this polynomial, this binomial, has a degree of 2, and it is called a binomial because there are 2 terms. Okay, degree of 2 binomial, or a binomial with a degree of 2. Okay, let's look at this one. We want to put it in order, but we notice something first here. We have a 4x and a 7x. Those are like terms. So I need to put those together. And when I put those together, I get 7 plus 4 was 11x. Okay? Now that has a degree of 1. This has a degree of 3. So it's got to go before the 11x to be in standard form. There's a plus sign, that's positive. Then this has a degree of 0. It's got to go after the x. Okay, now this is in standard form. Degree of 3, degree of 1, degree of 0. This is a trinomial because there are 3 terms. It is a polynomial also, but this is a more specific name for it, with a degree of 3. 3 is the highest out of the 3, so it's a degree of 3. Okay? Last one, standard form. Well, this has a degree of 2, this has a degree of 1, this has a degree of 0, so I put the x squared, 8x squared first. I put the 2x second. I put the minus 3 last. This is a trinomial with a degree of 2. A degree of 2. Okay, so we saw a binomial, we saw 2 trinomials, and again, if we just had a monomial, it's automatically in standard form because there is really no order to put here. It's there. But that would be a monomial with a degree of 5. Okay, a monomial with a degree of 5. Okay, that takes care of example 3. 2 more examples we need to cover. Example 4, we're going to add polynomials. Simply add them. I'm going to show you 2 ways. Okay, our book kind of does it 2 ways, and you may see it 2 ways. So I'm going to show you the first way, which is probably the least popular among students, but every once in a while I have a student that likes to do it. So when we're adding these, we're going to add them like we would add numbers vertically. So we're going to put this first. Really doesn't matter when you're adding which one goes first, but we're going to put this one first. And we put minus x, we put plus 9. Underneath it, we put this expression, and we line it up with its like term. So I'm going to line that up with the x squared. I line that up with the x, and I line this up with the 9. Okay? So now I just simply add. Okay? So 6x squared and negative 4x squared gives me 2x squared. The next one, negative x and positive 8x remember that's a negative 1x, that gives me a positive 7x. And then positive 9 and negative 4 gives me a positive 5. Okay, all those are positive, so we have plus signs. And that's it. That's how you do it. Okay, the other way to do it, I'll do one more like this in case you want to do it that way. The other way to do it is just basically matching up like terms and putting them together. Okay, which is less work. As long as you're keeping up with your numbers there, it's not hard. Okay, let's look at this one. Now, actually, I'll do this one. I'll stack this one. I'll just do this one with like terms because this one's a little different. So when you're doing this, you want your answer to be in standard form. So when I'm adding these, I want to look in both parentheses and take the highest degree first. Well, notice I have a degree of 2 here and a degree of 2 here, so I'm going to do that one first. I put them together, and I get a negative 5x squared. Negative 5x squared. And we want this in standard form, so I want that to be first. The next highest degree is a degree of 1 here and here. Well, I'll put those together. That's a negative 10x, so minus 10x. And then the last is the 18 and the negative 10. That gives me a positive 8. And there is my answer. When I add those polynomials, this is what I get. And it's in standard form because I have a degree of 2, degree of 1, degree of 0. Okay, let's look at this one stacked. It really doesn't matter since you're adding which one you put on top. I'll just put the negative 6x on top, minus 5. Okay. Now when I'm doing this one and I'm stacking, the 9x goes under the 6x. Okay, so I've got to put that there. The 5 goes under this 5. And this 5x squared is kind of off on its own because there's not another like it. So that's what it looks like. Okay, in adding, these go away, they cancel out. Okay, so there's nothing there. Adding these two, same sign sum, so that is going to be a negative 15x. And basically you're adding a 0 plus 5 and you get 5x squared. So it's 5x squared minus 15x, and it's definitely in standard form. Okay, definitely in standard form. Okay, let's look at the last of the adding polynomials, the last of the adding examples. So again, I look at both parentheses. Okay, and I'm looking for the highest degree. Well, it's here. There's not another thing to add to it. There's not another like term, so I'm going to go ahead and start writing my answer. That goes first. Nothing changes it. Okay, so that's gone. I find the next highest degree, and I find that's right here. And I notice that there's no other term with that degree, so nothing changes it. Okay, so now that's gone. Now I see that there is a 3 and a negative 10. Those are both the same term. They're both constants, so I add those together, I get a negative 7, negative 7. So this is my answer. It is in standard form. Okay, 15x squared plus 8x minus 7. For the last set of examples today, I'm going to show you both ways of doing these also. This one's a little more tricky with minus signs, okay? But it's an easy fix. You just got to remember to fix them. Okay, so the way I do these, or I like to do these, is to, let's say we're going to stack this one. Well, if you're subtracting, you need to put this one on top, okay? Put the first one on top. So I got negative 6x squared minus 5x plus 4, okay? And I've got a negative 3x squared minus 6x plus 8. Okay, but instead of adding, we are subtracting. And when you subtract, like you subtract a negative, becomes positive. So I think it's really best basically to take this and distribute that minus sign inside the parentheses and then add everything. Okay, so if we're going to subtract, we're just going to distribute this. So this would become a positive 3x squared. This becomes a positive 6x, and this becomes a negative 8. And we could have done that before we started, which we normally do, but I'm showing you this way. Okay, so when I distribute the negative sign, that doesn't exist anymore because it's now in the parentheses. Now I can simply add because that minus sign's gone. Okay, so negative 6x squared, positive 3x squared is negative 3x squared. Negative 5, positive 6, that's a positive 1x, or just x. Then a negative 8 and a positive 4 is negative 4. And you're done. This is standard form, and it looks great. Okay, let's erase that, and let's go to the next one. If I can find that, there we go. Okay, the next one we're just going to do with like terms. So before you start, you have to change this to addition. You don't really have to. It just makes it a little bit easier on you. So if I change this, I distribute that minus sign inside the parentheses. So that's that. That one's negative, and that one's positive now. Now it's all addition, okay? So now I scour the parentheses to find the highest degree term, and I've got one here of degree 2 and one here of degree 2, and I add them together. That is negative 4x squared. Okay, negative 4x squared. That's gone. That's gone. Okay, now the next highest degree term is a negative 7x and a 3x. That's negative 4x. That one's gone. That one's gone. Now negative 8 and positive 15 is going to be positive 7. And there's my answer in standard form. Okay, in standard form. Let's stack this one, and then we'll just do this one in the regular way. So I've got negative 3x squared plus 5x, and below that I've got negative 5x squared plus 3x minus 12. Okay, now I don't have anything over here. If you want to put plus 0, you certainly can for a placeholder. You don't have to have that, but in case you want to do it. And we're subtracting. Okay, so line here, we are subtracting. I don't want to subtract, I want to add. So I'm going to distribute that throughout the parentheses. So we're just going to forget that's there, and we're going to make everything in here opposite of what it is. That becomes negative, that becomes positive. Okay, now we're ready to go. We're just going to add now, not subtract. That gives me 2x squared. That gives me 2x, and that gives me 12. Turns out real nice. Okay, 2x squared plus 2x plus 12. Okay, last one, we're simply going to do it the best way, I think. Okay, we want that to be plus. I'm going to distribute that in the parentheses and make that a plus. So that becomes negative, that becomes negative, that becomes positive. Now we add like terms. We have a degree 2 here with a degree 2 here. Those are the highest, so we're going to put those together. We get negative 8y squared. We have a negative y and a negative y. Well, that is negative 2y. Then we have a positive 9 and a positive 12. That is going to be a positive 21. Positive, that looks like a 4. That's a y. So our final answer here, negative 8y squared minus 2y plus 21. It is in standard form, which it needs to be, and everything's good here. And that is subtracting polynomials. Can't say it. Subtracting polynomials, and that takes care of our lesson today.